Okay, so good day to you all. You're all very welcome to today's exclusive sneak preview of our upcoming release of nQuery and nTerim 2.0. My name is Eoghan Murphy. I'm a statistician with Statistical Solutions. I was part of the team that actually developed this software. I'm joined today by my colleague Andrew Grannell. Andrew is an experienced statistician who has kindly offered to field any questions you might have throughout today's demonstration. So if you have any questions, comments, feedback, you can just type them into the chat box on the right hand side of your screen. So please let us know what you think. Customer feedback was the main driving force behind our latest release, so we do really appreciate your feedback and your comments. So please, as I say, if you add these into the chat box on the right hand side of your screen, we'd be delighted to hear from you. Okay, so before we begin, if you find that the screen is maybe too large or maybe even too small for you, you can adjust the size of the screen by clicking on the drop-down arrow again on the right-hand side of your screen. There should be a toolbox there on the right-hand side where you can edit all these things. Alright, so let's get started. So here's just a quick outline of what I'll be doing today. I'm aware that there's quite a large number here, and there are some people here who maybe don't know what power or sample size calculations is or involves. So I'll just be starting off by just going through a quick definition of power analysis and just the reasons for doing a power analysis. Again, this will be 2 slides, very brief. Before again, I'm moving on then to actually nQuery and nTerim 2.0, where I'll be detailing the new tables, new features, and new plots. And then, of course, I'll be showing you the software itself, by just giving worked examples to give you a feel for these new tables, these new features, and these new plots. If we have time at the end there, then we'll go through some of the so many questions or comments that you may have. Again, as I say, Andrew is here with me today, and Andrew, if you have any questions, he will answer them for you throughout the demonstration. And again, look, due to there's a large number of people here, so sometimes we don't get to everyone. So again, don't worry if you haven't answered your question during the demonstration. We will get back to you within a few hours of the demonstration ending with hopefully an answer for you. Alright, so to begin, what is power analysis? Well, power of a study reflects the probability that the study will be able to detect a true effect of a specified size. So that is, power is the probability of rejecting the null hypothesis when it is in fact false. So you might ask, why should I do a power analysis? Well, the first reason is that a power calculation not only estimates how many people you need, but how many you don't need in your study. Power analysis can also be used as a guide as to where you can maybe tweak your study to possibly increase power without increasing the actual required sample size. Another reason where you should do a power analysis is that many studies have very low power and are poor sources for basing your own sample size on. So before you begin your own study, it's a good idea to do a power analysis for yourself. And finally, it's crucial to arrive at a power analysis is just crucial to arrive at valid conclusions. So, for example, if your power analysis indicates that you need maybe 1,000 subjects to define significant results, but you are limited to say maybe 50, then you simply do not do that study. It'll be a wasted effort. Alright, so nQuery and nTerim 2.0, what's new? Well, when we set out to develop the new release, we looked at it in 3 key aspects. New tables being one, which we're looking at maybe which tables we could add, which tables our customers wanted to see for which tests to calculate power and sample size. So we've added some new tables to our new release. I'll be going through these later. We've also then looked at features, so how could we improve upon the usability of the software for our users to make it more easier and just more intuitive in general for customer usability. We also then, again, based on customer feedback, we've added some new plots to the software. So here is just a list of some of the new tables that we've included in nQuery and nTerim 2.0. As you can see, we added some tables for repeated measures, MANOVA, and COVA. We've also added an option for early stopping for fertility in their group sequential trials offering. We also, what I don't have detailed here, but what we've done is also improved upon some of our existing tables. So some of the features, one of the key aspects of what we've done with this new release is that we now have nQuery and nTerim are fully integrated. So nTerim is now fully integrated with nQuery. Again, I'll show you this later, what exactly I mean by this. We've included some more options, some assistance that'll, again, as you say, improve the usability and just make things easier for you guys and make things more intuitive for you when you're using the software. Again, as I say, we added some new plots, so we've improved upon our power versus sample size plot, we've added some additional boundaries plots, some spending function plots. Again, this is all driven from you guys, from you, the users, from when we meet you at demonstrations and at web or seminars around the world. We just get the feedback from you guys, what you want to see, what you'd like to see in the software. That's our driving force. Okay, so let's go take a look at the software. Alright, so when you open nQuery and nTerim 2.0, this is the interface that you will see. Now here we have made some minor changes that we believe will have a significant benefit to you guys, the users. So you can see here along the top we've added some quick access buttons. So as I was saying earlier, nQuery and nTerim are now fully integrated, so you can choose between a fixed term test or an int-term test to start off. Then when you have your study design complete, you can quickly plot power versus sample size by clicking on this quick access button here for plotting power versus sample size. Over on the right hand side here you'll see that we've included two support buttons. Now this first one is for opening the manual. This allows you to quickly access relevant content. So what I mean by this is that, say for example you were opening the ANCOVA table, one of our new tables, and you're working away on calculating your study design, your power versus sample size for the ANCOVA table. By clicking on this button while you have that table open, it will take you directly to the ANCOVA section of the manual. So again, it just helps you to quickly access the relevant content. Now next to this button we have our Statistical Solutions Support button. Now what this does is this takes a link to our support page. So by clicking this button, your default browser will take you straight to our support page. Here then you can submit any question you may have, and generally you'll receive a feedback. We say within 24 hours, but I'm told it's closer to actually 1 hour. So here you can ask any questions, be they technical just on the software itself, on how to use the software, or just any general sample size or power calculation questions you may have. Again, we're delighted to hear back from any of you. We'd gladly help anybody in this regard. Also on this page you'll find frequently asked questions and other helpful documents. So at the top here, also what we've added is that in the assistance we've increased our assistance offering and our plots offering. Okay, so to begin, if we click one of these buttons here, so we start doing a fixed term test, it'll open the study goal and design window. Here where we've added, as I say, we've now integrated nQuery and nTerim. So our study goal and design window has been extended to the first question being whether you're starting off doing a fixed term analysis or an int-term analysis. So just for those of you who maybe aren't familiar with our software, what this study goal and design window does is that there are quite a large number of tests on offer in the software. So what this does is it helps you to quickly narrow down the test that's most appropriate to you. So just by clicking on the buttons here, so click maybe say two groups, test for analysis method, means being our endpoint, and a fixed term analysis. And if we just open, we say one of the new tests for repeated measures for two means. So you see here we have the similar interface, the spreadsheet style interface where you can input your values, and also we have their guide card on the right hand side here, which offers you helpful advice on what exactly you should be entering here for each section of the test. So it gives you input advice and tells you the options that you can enter here. Okay, so this table is used to calculate power of sample size for the time average difference between two means in a repeated measures design. This is a design that can lead to more precise estimates and can help avoid bias from single measures. So you can see here on the right it gives you a description of the test, it gives the references. Alright, as I was saying, you can input your values here directly into the spreadsheet here, or alternatively, what you can do is use the specify multiple factor table, which we've now included into this test. So this is what I'm going to use here. This is particularly helpful if you're doing a sensitivity analysis on one particular parameter. So here what I'm doing is I'm entering a range of values from 0.6 to 1, and I'm going to look at these values in steps of 0.1. So I've entered 0.6 to 0.1 my range, and to 1, and I want to look at it in increments of 0.1 So I'm doing a sensitivity analysis on the difference in means here. Also in this table, what I can do is I can enter a list of values instead of entering a sequence of values. So here I'm just going to enter a list of values for the between level correlation. And in this example, I want to solve for power, so I'm entering my sample sizes. So once I'm happy with what I've filled out, I click Fill Table, and this will fill the table for me with all possible combinations given what I've entered. So for my example here, what I want to do is I want to calculate the power. So from the drop down, I select Calculate Attainable Power with given sample sizes. I want to do it for all columns, so I click Run, and nQuery and nTerim will automatically calculate the power here for you. Now, the output statement is given at the bottom of the screen here, so you're clicking on the Output tab here, and this updates depending on which column you're on. Now, it's also, as I showed earlier, we also give you can do a plot of power versus sample size very quickly by clicking on the button at the top here. So I want to do plot of power versus sample size for my first 4 columns. So I've highlighted the first 4 columns here. By clicking power versus sample size, I get a plot of power versus sample size. Now what we've done here is that we've also added a slider to this graph. So you can move the slider along the graph and it'll show you the power and sample size at each point on your graph. You can also move between graphs then by simply moving the slider across. It'll give the power versus sample size at each point that the crosshairs is on. Here you can also edit the legend here on the side. So for instance, you're looking at 2 drugs, you're going to compare a placebo. Standard. And you can enter whichever you want to do here. Drug A, drug B. Click OK, and the legend updates on the right hand side for you. Now once you're happy with your graph and happy with your legend and you want to store your graph, what you can do is just simply grab your graph and snap it in at the bottom here. So the graph is now stored. So down the bottom here, what we have now is our Specify Multifactor tab, our Output tab, our plot of power versus sample size. So then if we wanted to maybe open up a new test, so you can just easily open up a new test again by clicking on our Quick Access buttons again at the top here. So if we look at, let's say, one of our new tables again, we look at the analysis of covariance. So you just click on analysis of covariance. Click OK. So you can see here, you can simply interchange between the tables here by alternating between the tabs at the top. So here we're on analysis of covariance. This is this table here is used to calculate power and or sample size for analysis of covariance. Again, we have our guide cards on the right here, which tell you the entry options for each parameter which needs to be inputted. Okay, so for this example, again, I'm going to use the Specify Multiple Factor table again to quickly add in multiple parameters into my table. So here for number of groups, I'm going to enter a list of values, so I'm entering 2, 4, and 6 groups. Now I'm going to leave variance means empty here for a second. I'll come back to that. So again here, I'm going to enter a sequence of values from 0.2 to 0.6 in steps of 0.1. Now for this example, I'm going to solve for sample size, so I'm going to enter 90% for power. So I'm going to click Fill Table, and the table again automatically fills for each combination of the parameters that I've entered. Now the only parameter I've left outstanding here is variance of means, V. Now the reason I left this outstanding is that there are 2 options you can do to input values here. You can input the value of variance of means directly if you know it, or alternatively you can use our Compute Effect Size Assistant here, where you can enter the means and nQuery and nTerim will automatically calculate the variance for you. So see here, we've entered 2 for the number of groups, so we enter 2 means here. So I'll just pick these arbitrarily, say 24, 26. So nQuery and nTerim here will automatically calculate the variance means for you. Once you're happy with this calculation, happy with the values that you've entered, you can click Transfer, and the value is transferred to the table for you. Now, if I wish to do the same compute effect size for each individual column, I can do this by simply selecting the column here. And again, as you see, the effect size table automatically updates for you by entering the 4 groups here, or for column 3 where I have 6 groups, so you entered 6 means here. But I'm happy to stick with the 1, so I can just click this and fill right, and it'll fill right across. Now say for this example, we're calculating the sample sizes for a given power, so select calculate required sample size for the given power, all columns, and clicking run, nQuery and nTerim will calculate the sample size for you. So as before, you have the similar output here. Again, you click on column 1. At the bottom here, it'll give you your output statement automatically generated for you. Again, you select onto column 2. This output statement gets updated to column 3, 4, and so on. Also, as before, you can just again highlight the columns you want to use. Select plot of power versus sample size, and plot of power sample size is given for you. Again, you can edit the legend here, but again, store it down here. So you move in. Okay, so perhaps now you want to do, we'll say, an nTerim analysis. So we're going to click here and do an nTerim analysis here. So you see here, by clicking this button, the nTerim analysis button is automatically selected for you, and the options which are unavailable are grayed out. So here we're giving endpoints for means, proportions, and survival for nTerim analysis. So we click on survival. So we want to do sequential test for 2 survival curves. So again, this opens as a tab at the top for you. So again, you can alternate between these tables just by selecting on the tabs. Now, this is as I say, this is a group sequential test or nTerim test. Now, these differ now from fixed period trials that we conducted previously, in that the data from the trial is analyzed at 1 or more stages prior to the conclusion of the trial. So as a result here, the alpha values applied at each analysis or look must be adjusted to preserve the overall type 1 error. So this is why we have extra rows here, as you see here on the left side here, just to add in the alpha spending options and add in our number of looks. So again, you can use the specify multiple factor table here to input your values. But for this example, I was going to enter the values manually. Now for this example, what I wanted to do is compare the different spending functions that are on offer here. So I'm going to keep the parameters the same to see how the power varies per spending function. So here for this first column, I'm going to look at O'Brien-Fleming spending function. For second column, we look at Pocock. And the fourth, Huangshi-Dicani. Okay, so again here we have inputted a value for sample size. So what I want to do here is calculate the attainable power with the given sample sizes. So again, I want to do this for all columns that I've inputted parameters for. Clicking run, nQuery and nTerim will then calculate the power for you. Now you can see here that there is additional output given here for the group sequential trial. So what we have here again, as I say, for the looks for the alpha spending function, we actually have a table here which gives you information on the looks. So it tells you the bounds, the lower bound, upper bound. So here for column 1, which we have the O'Brien-Fleming, you can see here the early bounds are quite conservative. There's also on the bottom right here screen here that we have given what we call a boundaries graph. This boundaries graph here, you can see again, this is for the O'Brien-Fleming. It's quite conservative to start, it narrows off towards the end. Now also what we have given here is that you can do a plot of power versus sample size. Again, just like for the fixed period trials, you can do plots of power versus sample size. This is given here for you. Again, you can just snap this in here. You're given your output statements again, just like for the fixed term analysis. So you can see here on the bottom right as well how your boundaries graph updates automatically as you alternate between your columns. So your boundaries graph and your output statement both all update as you move between columns. We've also included some additional plots here in further group sequential offering. Again, this is all based on the feedback that we got off you guys going for conferences, going to seminars and webinars and all the rest of it. So here, what I want to do here is plot my 4 spending functions on top of one another to see how they look compared to one another. So click plot, spending function plot here. So you can see here how the 4 spending functions compare to one another for the 4 columns here. So the legend here gives you the information on the spending functions that you've used. So you can see here the O'Brien-Fleming again is quite conservative at the start, whereas you say the Pocock and the Huangshi-Dicani are quite uniform across in their spending of the alpha. Now we've also added in the for our group sequential offering, again based on the feedback that we got off you guys, is essentially an inverse of our current boundaries plot. So by clicking on our plot here, we're going to do a boundaries plot here. You can see here, this is just essentially, as I say, it's just the inverse of this current boundaries plot here, but it's just an additional different plot of the same, essentially the same graph. Okay, so that's what I have to show for you. So on the latest release of nQuery and nTerim 2.0, I hope you enjoyed the demonstration. I hope you like the software. Again, if you have any comments about what you saw here today on nQuery or nTerim, or you have anything you'd like to see in nQuery and nTerim, then please let us know. We'd be delighted to hear from you. As I say, we value your opinions greatly. Your opinions were the driving force behind our latest release. So again, we'll just give a few minutes there. If anyone has any specific questions they'd like to ask us, we'll be here for the next few minutes. But again, as I say, if we don't get back to you within the next few minutes, we will get back to you before the end of the day, or within 24 hours of the demonstration ending. Just due to the large numbers that are in attendance here, there's quite a large attendance, so we won't get around to every question. So just on behalf of Andrew and myself, thank you all for your attention. It was lovely demonstrating for you, and I hope to see you back here again soon. Thank you. Okay, so we just have time for one or two quick questions there, and quite conscious of time's nearly up here for our allotted time for the demonstration. One person is asking, just is nTerim, our interim analysis, is that for group sequential designs or is it for adaptive designs? Currently, what we're offering in our interim analysis is for group sequential designs. So again, thanks very much for your questions. Just another question in there, there's a person asking to just quickly expound on what the boundaries graph is. What this is that, as I say, in interim monitoring group sequential trials, multiple looks are taken at the accruing results. So in such circumstances, in order to preserve the overall type 1 error, the alpha is spent, and these spending functions establish these adjusted alpha values for each interim monitoring point, giving the overall alpha. So typically here what you have is that they establish relatively high values for the earlier looks and lower values for the later looks. So what they do is that's for the O'Brien-Fleming. So what they do is that they constitute stopping boundaries, which when these boundaries are crossed, they indicate statistical significance has been established. Okay, so that about wrap things up. Once again, thank you very much for your attention. Again, I hope you enjoyed the demonstration. If you have any questions or comments, keep sending them in. We'd be delighted to hear from you. So once again, thanks you very much for your attention.